This video states some novel observations and related to the Collatz conjecture and proves them. Its aim is to inspire people with the beautiful and simple patterns underlying mathematics. Now, I want you to do some mental mathematics. Take a positive number. For ease, keep it below 10. Follow the rules on the screen. If you want more time to explore, pause the video. If you calculated everything properly, you should have ended up in a loop which went 1, 4, 2, 1. In fact, the Collatz conjecture states that all natural numbers end up at 1 following the same steps. Here are the patterns followed by 10, 100, 1000 and 10,000. Notice how they seem to be moving randomly like hailstones. Therefore, a sequence of numbers following the rules stated earlier is called a hailstone sequence. Now we will derive a novel Collatz representation of natural numbers. Now, if we go backwards in a hailstone sequence, a possible sequence could be as on the screen. Notice that in any step, we can multiply the number by any power of 2 and increase the steps by that amount. Repeating the backward sequence, we can interpret the conjecture as one stating that any natural number can be represented as a form shown on the screen. We will x, y, r, and so on digits of a number in its Collatz representation. For example, the representations for 44 and 45 are given. There are some important points to understand for the representation. Number 1 is that removing 1 from all digits divides the number by 2. This can be easy to understand when one sees that this equates to dividing the numerator in the given equation by 2. Number 2 is that removing a 0 as the last digit gives the next number in the hailstone sequence. This has a slightly more than trivial proof given below for reference. As a result of the above two, it is very easy to prove that the requisite number of steps is the sum of number of digits in the representation and the first digit, 1. Consequently, changes only in the first digit and number of digits will produce a change in the number of steps. An interesting observation. The number of steps to reach 1 for 12, 13, 20, 21 is given. Notice how they are equal for the consecutive numbers. In fact, it is easy to notice that for any number that is a divisible of 4 and not 8 and that number plus 1 give the same number of steps. This can be restated as the following conjecture. This becomes a corollary to the Collatz conjecture because it assumes the Collatz conjecture is true. This can be easy to prove as shown. The last equation shows that the only change is that the last digit changes from 2 to 0. We can extend this to the following corollary and prove it using two proofs. We can extend this to any number of digits in the Collatz representation of a number. In conclusion, we can see that simple patterns can produce powerful results in mathematics. Do like, share and subscribe. Thank you.